everybody, we have made it to our last video. So congratulations, that's exciting. Today is going to be our day 4 lesson, and we're going to be talking about limits as they approach infinity or negative infinity. Just slide this over here. So in order to do that, let me look back at the notes from the previous lesson. So I think we left off on one of these examples here. So in all of our other lessons, we were looking at the limit as we approach a value like a, or 2, or 10, or -5. We approached it from the left and right together. We approached it in this lesson just from the right, just from the left. This was like our previous lessons. So now we're just going to look at not approaching a particular number or value, but just approaching either infinity or negative infinity. So if I look back at this lesson, hold on one second, here we go, I just need a pencil. If I look back at this lesson here, if I wanted to see the limit as x approaches infinity here for this graph, all that means is, okay, as we go to further and further to the right, where does the graph go? Okay, and so you can see in this one, it seems to be approaching some sort of asymptote over here. And so that's something that we would have to figure out, what is that asymptote, okay? Now, if the graph were something simple like a line, x, y axes, that might be a little bit easier to figure out. So the limit as x approaches infinity means, okay, as far right as we can go, where does the graph appear to be going? And the graph, as far right as you go, will continue to go up. So in this instance, I would say the limit as x approaches infinity of this graph that I just sketched out would be infinity also, because it's going up forever. So as x gets bigger, you can see the output of y's just get bigger. So what we're going to look at today is more examples like we saw here. What happens when we have these asymptotes like that? And how could we easily figure them out? So this is kind of what I just mentioned a second ago, the topic of our lesson. And what you're going to see different today than other days is instead of x approaching a number, it's just going to say x approaching infinity, or like this example, negative infinity. So as we get closer and closer to the right of a graph or to the left of the x-axis, where does a graph end up going to? And oftentimes, if it's a fractional equation, there'll be an asymptote. So let's take a look at my first example down here. The limit of f of x as x approaches infinity. Okay, well, f of x is going to be defined as 1 over x. So when you have a fractional situation like this, and I'm focusing on the fractions because like you just saw a second ago, that graph of a line, it's easy to see where the graph is going. It's going up to infinity, or even, I'll come back to it. As x approaches negative infinity, the graph goes down to negative infinity. So that's pretty obvious. So I'm working more with examples like this today where the graph isn't always easy to view. It looks like this in your graphing calculator. You can go ahead and type it in. So here's some quick things to note when you're working with fractions, So do you see in this fraction here, there's just a constant in the numerator and the variables in the denominator? So when you have that situation, it will always equal 0, and here's why. As x gets bigger, let's try subbing in some numbers like 2, 3, 4. Look what happens to the graph. It gets smaller. These numbers get smaller and smaller and smaller. And they're going to get closer and closer to the number 0. Okay, 1/8, 1/10. Think about it. If I put in 1,000 here, 1/1000th, 1 over 1 million, those numbers are going to get really, really small and closer to 0, but they will never get to 0 as x approaches infinity. Because again, these numbers are just going to get bigger and bigger and bigger. So 1 over a really large number would get closer to 0. So long story short, again, when you have the situation where you have a constant over an x value like this, it'll always equal 0. You can also validate it by looking at the graph. The reason why I'm focusing on the equations more than the graphs for these problems is because sometimes these problems are just hard to see where is the asymptote when you're just looking at your calculator. So we'll go through a couple situations here. So now I'm going to show you a situation What happens when the degree of the numerator is the same as the degree of the denominator? The degree, again, look at the biggest exponent, is a degree of 1, degree of 1. Now, of course, we normally don't write it there. I just wrote it there just to show that they're the same. So when the degree of the numerator and denominator is the same, the answer of the limit is just the ratio of the leading coefficient. Okay, so if I look at the ratio of the leading coefficient is the number in front of the variable, okay? And not just any variable, the leading variable, so the biggest one. So 3/5, those are the numbers in front of the variables here. That is your answer. It is the same story with this guy over here. If the exponents are the exact same, okay, the biggest exponents are the exact same, so therefore the degree is both 1, then you just take the numbers in front, 4/2, and then since this reduces down nicely to 2, that's it. Last time it didn't reduce, so we just left it as 3/5. This time it does reduce, so we leave it as 2. Okay, so we talked about what happens when there's a constant over a variable. And that can be any variable. It can be 1/x², 1/5x. As long as there's a constant over a variable, it'll always equal 0. If the exponents for the degree are the same here, you use the coefficients of those terms, and that ratio will be your answer. Same here. 1 and 1, the degree is the same. Use the coefficients, it reduces to 2. All right, so now in this instance, this is kind of going back to the first example I did with you on the previous page here, 1/x. This is similar in a sense that the degree of the numerator is smaller than the degree of the denominator. So as long as the degree of the numerator is smaller than the denominator, then you're going to have that same situation as the previous side, where it was 1/2, 1/3, 1/4, etc. You're always going to get the denominator to be approaching, let me say that again. The denominator is going to be getting larger faster than the numerator, okay? And so since that's happening, you will again equal 0. So again, one last thing, the degree of the numerator is smaller than the denominator. Therefore, the denominator is going to get bigger faster. It's going to get bigger faster than the numerator is. So therefore, you're going to have that situation again where, let me just again make up numbers now. You know, let's say we have 1/2, 1/3, 1/4, 1/10, 1/100. The denominator is going to get bigger faster. And this makes for a smaller and smaller number that gets closer to and approaches 0. So the only other situation we have left to talk about is what happens when, sorry for this little mess here, what happens when, oops, this is the same story, I'll go back there in a second. What happens when you have a situation like this, where the degree of the numerator is larger than the denominator? There's actually two things you're going to do. If we were in class, I would show you both ways, but I'm going to show you the shortcut. The shortcut is, right here, is what's called the end behavior model. You just reduce the first leading terms and look at the end behavior of that graph. So the leading terms would be x to the fourth, 1x to the fourth, over 7x². If I reduce these terms, I have 1/7, got it, x to the fourth over x². When you divide, you subtract exponents to be x². So that makes a parabola, okay? Looks in something like this over here. So this is what you look at, the end behavior of this parabola. And as x approaches infinity, as we go right, where does the graph go? It goes up to infinity. Therefore, that's your answer. Now, I skipped over one. Let me go back to it. In this instance, we had another example where the numerator's degree is smaller than the denominator's degree. And again, in an instance like that, when this degree is smaller than the denominator, then you're always going to approach 0. okay, because this denominator is going to get larger faster than the numerator is, and that's going to create one of those scenarios where, again, if you have 1/2, 1/3, 1/4, 1/5, 1/1000th, those numbers are going to get smaller and smaller and smaller and closer to 0. So those are the situations that you could possibly come up with for limits as we approach infinity or negative infinity. And again, I focused on these more interesting scenarios with the fractions, mainly because when you graph ones like these in your graphing calculator, it's not super simple to see where the graph is approaching. So that will be a wrap, guys, on videos. Congratulations, my seniors, and we will have a test posted shortly and a bonus activity next week if you'd like to do that. So that's it. Signing off one last time. Take care.